Welcome to r2con. This year, in 2025, we are going back to the roots. Yes, you did it. You'll find the link of the playlist with all the videos of the very first day of the conference. Tomorrow we'll have another link with the playlist of the second day. So get ready, pull the last changes from Git, grab some popcorns and get ready to learn, discuss and share. Like we did in the very good old days. Let the roots grow again. And yes, this is the best conference that we have in r2lan. It's a good opportunity to bring our digital selves together for a couple of days to share the projects we have been working on with passion and this year. It's actually, next year will be 20 years old. And it's actually not the resources that keep us going, but the roots, our community, our passion, having fun, and sharing the stuff that we do. So let me introduce you to the conference. Organizing a conference is a lot of work, and making it in real life, it requires more resources, more time, more people, more money, booking flights and so on. So there was actually so many things going on, and I decided that would be good to have an opportunity for everyone that wants to share the work that they've been doing just online. Having the whole conference online simplifies a lot the organization. So I opened the call for papers, and I was receiving many mails from people wanting to share the projects that they have been developing during the year. So I managed to fill a couple of days, and all the speakers will be in the chat. So you can join the YouTube chat, Discord, and Telegram channels to talk with them. And also, if you like to share anything of the conference in the social media, I will recommend you to use the r2con2025 hashtag. And maybe next year we'll have the time and the mood to organize it physically again. So let's talk about the website. You will find the links of all the presentations with the description, as well as an iCal file that you can download and install in your calendar app. This way you won't miss any link or the presentations that you like. And also, for the very first time, we are DLOG compliant. This means that the website visualizes properly in an HTML 1.0 browser. Also, I would like to thank Neuroflip for all the music that he did for the presentations and the conference. So I was playing with a R2AU and R2AI in order to make some music. If you know about R2AU, well, basically it's a plugin that I brought maybe 5 years ago, 6 years ago. It was basically a plugin that extended the command line of Radare to have a way to play music. So you can create waves in memory, you can play them, and you can also combine them together. And making some R2 scripts, like the one that you can see in the slide, you can actually R2 play music. So I basically teach R2 AI how to use R2U. And this way, I managed to get some music automatically generated with a language model. That was fun, but probably not enough. So I shared all the proof concept with Neuroflip, and he was playing with all that, and he ended up making some music with Strudel, which is the one that you will be hearing during the conference. So let's review the changes that we had in the project since 5.9.6, which was the version released in the last conference, to the 6.0.4, which was the last release that we have. Actually, there is more changes since this release, so hopefully after the conference, I will be releasing the 6.0.6. There is some development and changes in the project. Now we are breaking APIs again. As long as we switch from 5.0 to 6.0, we can break major APIs. And this means that you will need to recompile all the projects. But don't worry, there is more guardrails in the plugin loading things that basically verify that the API version is the same. Otherwise, the plugin will be loaded, and the plugin won't be loaded in a way that it will be charging all the libraries that the plugin is, or not even executing the constructors of the plugin. This means that you will probably not get any sigfold if you have old plugins loaded in your directory. Also, we have an auto-formatting script. This is something that is far from perfect, but finally, the thing is that the CLang format is still not able to indent the code of Radare. The reason for that is because not because Radare is having a strange indentation rules, but because Radare's indentation is inspired by the GNOME project. Um, so GNOME is not even able to indent the code nowadays. So they have to indent things by hand or patch some Perl scripts on top of that. And they use Crustify sometimes and so on. So it's actually indenting C code is not that easy. It's not something that you can just delegate to a program. So after a couple of thoughts, I end up like realizing that the only way to go is basically get CLang format as a base tool and then parse the output that we generate with that, which is kind of like pretty stable, and then adjust the output to make it fit to the Radar standards. So now you have the CLang format Radar 2, which is a script that it's installed system-wide, and you can use that to indent all the source code that you have in your Radar plugins or anything, any contribution that you do to the project. Also, there is some important changes if you care about the plugins or updating any of the code that is using Radar. You will need to change the offset concept, which has been inherited since Radar 1, because offsets are not really conceptually absolute addresses. They are actually deltas since a specific base address. So now we're using address instead of offset everywhere. Also in the JSON output, this means that if you have any script using the JSON output of any command that references a memory address, you will need to change that. Also, the console library is no longer depending on global variables. This means that you have like a local state associated with the instance of core that you are using. And also what's cool of that is that you can have like multiple core instances in the same process without sharing the same console. And the important part of this is that the console is used as a cache layer for filtering and printing data. So in order to get the very first steps to get full thread safety and the implementation of Radare, that was an important change. This means that need to change like more than 60,000 lines of code just to update this library. But it's done. Also, there was a couple of important libraries that have been refactored. The parse library is now inside the ESM one, and this library was used to parse the output of the disassembly. There is a plugin that was developed by one of the speakers that will be speaking in this conference that used this library, and this helped us to redesign and implement it properly. And also we have the Muta library. The Muta library is a mix of charset crypto and hash APIs. The reason for Muta is because it's something that mutates some input into some output. And as long as encryption, encoding, like changing base64 or ciphering some data or converting a stream of bytes into a hash, it's just mutating something into something else. So I decided to make a unified library for all that. And also all the chartsets implementation fits into that design. So I basically refactoring all the plugins and logic to make it work in a simple way. Also, there is some progress in the project side. It was a very long requested feature, and actually projects work. But the point is that if you try to use projects on large binaries or multiple configurations, like having different memory layouts, different files loaded, and stuff like that, it doesn't work. Or at least it won't work in all the use cases. So after thinking a while about that, I decided that we need a new file format. And this is implemented in a plugin. This was already presented last year, but I think it requires more attention. So I'm trying to explain that now. So the new file format is extensible binary file format. You can include any data inside these projects, it means that this file can contain files inside. It can also contain scripts, but also, more importantly, it's including all the information from the projects like flags, function names, and all that stuff in a way that can be relocated in any address. And not just that, it's also optimal because all the strings are packed together in a single section and all the data is referencing that by offsets, which is pretty similar to the way that binaries work, like ELF or Mako. And this is pretty great for parsing, and you just need to allocate a single buffer and work that quickly. And also, there was an important changes in the flags management. The flags now contain all the binary related information. Like, for example, if you have like a symbol that contains manglet name, the flag will be also storing the manglet name, the manglet version, the flag string, and also if the user defines something else, also that. There's also the possibility to define colors to all the flags and all their attributes, like comments and so on. So please start testing the new projects so we can at some point be able to use them by default. In the Apple side, we have some main highlights that we introduced this year. We have iOS 26 support. This means that you can load the last dial-D catch, so thanks Francesco for that. We also have EOKit support, so thanks Ule Andre for this work. The Mangler for Swift is a zero implementation of the original one. It's not one-to-one, it's not perfect, but it works, and it works pretty fast and it's safe. So that's why we are choosing that and not linking to the C++ of the LLVM project. Also, BCNOS binaries can be loaded, but we are also supporting old stuff like the PF binaries. So this is from the MacOS Classic. The Motorola 68000 support has been improved also for the not just for the disassembly, but also for assembling and analysis. You can now assemble almost of the 68,000 instructions, as well as improve the support for PowerPC. Another important thing that was introduced is the fat macro support. Now we can load large fat macros, and by large I mean that larger than 4 GB executables. This was a small issue in the code, but we didn't catch that. And the cool thing is that they are loaded really fast. I mean, they load like few kilobytes binaries. And also, finally, thanks to Blue Yashi, we get all the DMGs signed in the CI. This means that you can just download the DMG from the release page and use it directly without having to reassign the binaries or having to bypass the zip configuration. And also this was helpful because Brio distributions are finally packaging Yaito. We have support for many new architectures. You can now run R2 in UEFI, so you actually don't need an operating system if you don't consider UEFI an operating system, which I do. But also you can run R2 in a WebAssembly. That's not new, but it was improved a lot because there is another presentation in this conference that you will see, which is R2 Web, that will be running R2 inside the browser. So we actually need to find and fix some of the issues that was blocking us to analyze large binaries and stuff like that. Also, we have pseudo disassembly for almost all the architectures. And pseudo disassembly is important for not just pseudo disassembly, but also for the compilation and AI-enhanced decompilation. So we managed to get support for decompiling all these architectures, like from BACS, SBPF for Solana, TMS, Plan9 binaries for RISC-V, and also 3-core STM8 microcontrollers and COSMAC 1806. For the packaging, as I said, Blue helped us to get all this stuff ready for Flatpak, not just for getting the DMG sign on macOS, but also getting the proper distributions for Linux. We have Flatpak and Snap support, and if you want to run Yaito, is probably the best way because it's basically packaging R2 inside, so you don't only have one single binary, and it's unboxed and runs everything inside. You can basically mess with your system, have separate R2 installations, and that won't be messing with the stable Yaito builds. Also, Sadco have been refactoring all the sub-projects code, so we are not shipping third-party projects in R2. And the main limitation of the main challenge that we had on that was basically we are maintaining make files and Mason builds at the same time. And sub-projects work well in Mason, if that means that you need to do some stuff to get offline builds to work. Because if you're running make and you need to download data from the internet, that's not an offline build. And also not reproducible build. So what we need to do was basically import the sub-projects implementation of Mason to make. This was done in ACR, and also we needed to find to distribute tarbles containing all the sub-projects inside. This is done, so you can basically download the tarbles directly from the zero release page and use that. Also, there is a bunch of CI improvements on the test suites, more stability, and also better support for XDG. And we have a custom LZ for decryption and encryption, compression and decompression library. This means that we're shipping like I think it was 400 lines of code instead of the 10,000 ones from the original implementation, and it's fast and stable and quite well tested. So we basically remove support some optional dependencies. And also we get Qt6 support because the Qt project fixed some of the bugs that we have been finding in the last releases. Also, in the future, we plan to eliminate global states. That's something that's not easy to do, but because it's not just removing global variables, but r2con was part of the project and the plan to get to the point. We have automatic flag spaces. This means that you can define a range of addresses that needs to be prefixed with some names. This was inspired with a presentation from Travis Goodspeed that when you are working on large binaries and you have static libraries compiled inside, like for example in firmwares or static programs, you can define where the beginning of one library and the end of that library, because this used to be packed inside the binary. So you can actually define a prefix for the flags that should be associated with an address range inside the binary. So all the analysis and search commands will be using that prefix when you work on that. So you can easily identify and group all the functions by library just like that. Also, we have import classifications. This means that when you enumerate the imports, you can see which imports belong to what. So for example, you can check all the network related imports. You can check all the imports that do something which is not thread safe. All the stuff that can be memory unsafe, like string copy or string cut, libc functions, etc. This is very helpful for analyzing or having quick looks to binaries and find out if there is something fishy that we need to analyze later for vulnerabilities. Also, we have a revamped support for forensics and remote file systems. So thanks, Mickey, for working on all that. And R2Pipe now supports HTTP post request. This is very handy because submitting comments of R2 in the get post is not probably the best way you can do, because there is some mangling and encoding with the URI code format that will be a little messy depending on implementation. This was proposed by the Java implementation that we will see in the R4 Ghidra presentation in this conference. And it's also implemented in C. This means that you can use HTTP post for R2Pipe in R2 as well as in Ghidra. We have new visual modes. We have like a midnight-like commander view for the file systems. Also, we have like a better view for analyzing all the flags, function names, and stuff like that. We have improved the memory allocations, getting faster seal, And we have a new C parser. And this is an important change because we are no longer depending on TinyCC for parsing types. We have a new C parser, which means that we have full control on everything. And it's not that we have full control on the way that we parse information from the types, because in C, you cannot represent everything. There is many constructions that cannot be represented in C, or they are tied to one specific C implementation. So we can add some metadata, and this metadata can be included in the comments of the C types. And another cool part of that is that now the C parser, or the types parser thing, is implemented as a plugin. So this means that you can create plugins in Go, plugins in Rust, plugins in the language that you like, and use that as a source for types information. So this means that you can include Go files if you write a Go types parser just directly in Radare. Right now we are only shipping the C parser and also the TinyCC one, but it's easy to create new plugins and extend the support for other languages. In the plugin ecosystem scope, we have r2Ghidra, which has been synced with the last Ghidra code from the NSA. This has been fixing very long-standing bugs like type propagation stuff and things like that, and also some strings that were not shown in the compilation. And this is also fixed now. R2Frida has been synced with the last version of Frida. Ule has been working on all the breakpoint support and also improving the TypeScript support inside the SDK. So R2Frida get benefit out of that. And now we have support for software and hardware breakpoints. So you can use R2Frida kind of like a debugger, not just like a tracer. And also you can observe the events for threads and modules. So when a program is loading a library like dlopen or loading the library when startup time, you can get a function to be executed. And in R2Frida, you can basically specify which R2 commands you want to run when that happens. And this is very helpful because you can actually automate in just one line so many actions that can happen when a specific thread is created or a specific library is loaded, just to do some early instrumentation fixes in that scope. Also, we fixed the remote file system support, so thanks Alex Murphy for that. Basically, all the information about not just the file name, but also the file size and attributes of the file are transferred in JSON from the agent side to the host side. And RFS, so file system implementation in Radare, can now properly load large files from remote endpoints. Yaito finally got stable. This means that we have stable builds for all the platforms, and also it is still like single-threaded, so you cannot expect working on Yaito for large binaries and things like that, but it will work for many use cases. Also, we get support for R2AI, the Kai, and there is a R2PM from 10. You can install any package for Radare, any plugin, just with the mouse. Just clicking, searching for the specific plugin, and you will get everything in the UI. There is support for more Beam keys in the UI, so you can use HGKL, the single quote marks, visual marks in Yaito, not just like in the terminal you do in visual mode in Radare, but also the ones that were inspired by Beam. There is also new widgets. You can check and configure the IO maps in Yaito. You can configure the whole memory address space and layouts using a Qt widget. There is also a file system widget and also art widget that can be helpful to find ASCII pixel maps and other stuff in ASCII inside Yaito. And all the symbol flags are now using relative information, so you can basically visualize the offset from the beginning of the map or the offset from the beginning of the a function that is one specific instruction, for example. This is very helpful when analyzing crashes or backtraces from different executions that you have ASLR, for example. And also, all the listings get improved defaults, and you will get better information. More plugins. The AI plugin ecosystem has been improved quite a lot. We have R2MCP, which was a plugin written by Dinakov, and it's written in C. It's now basically exposing all the R2 functionalities to AI agents. So you can use Visual Studio Code, Open Code, Claude Code, or whatever you like as a front end for R2. So you can analyze, get reports, get information, and use Radar without even knowing a single comment. R2 MCP has been improved a lot. It's more stable. You have support for sandbox. You can extend the tool with more more commands or scripts. It have more features, and also you can specify some restrictions, like connecting to one specific running session of Radare. So you don't need to create new instances of Radare. You can have your own session of Radare or Yaito, and then get the MCP to connect remotely to that session and interact with all the data you have. Also, it's not the only MCP. There is also R2 Copilot. I will be speaking about that in the Biber presentation. And it's another MCP for R2. This one is written in Python, but it's mainly focused on CTF. The thing is that there is a lot of challenges for security, like finding gadgets or reverse engineering some specific vulnerabilities that can be heavily improved if you use the R2 Copilot. So I will encourage you to try it out and give some feedback to the project. Also, we have the Kai, which was the basic R2JS plugin for the compiling with AI. And it's now supporting R2Pipe 2. It's also capturing the output of the error messages. And this was really important for detecting when the model was not understanding well how to type comments. And basically, now the model receives the error message from Radare, and as long as it just takes the output, it can act properly after that. There is a lot of refactoring in there, and it was a good playground to design the new decisions that we did in the rest of the projects. We have also R2AI. It was rewritten from Python to C, and it's now building and running in all the platforms, even on Windows. And finally, but not directly tied to R2, there is Mai, which is an AI framework that I've been developing to help on doing anything with AI. You can create like pipelines in the shell, you can prompt files, or you can do many things with local or remote models. And it fits very well with the spirit of Radare. So you can basically combine Radare with Mai and do whatever thing you like. With local models, like creating automated pipelines, calling tools without tool models, etc. So finally, I would like to say thanks, because without you, this conference wouldn't be possible. So thanks, Adri, for your patience with me, and also for editing all the videos that we will be seeing in this conference. I know that's a lot of work, and you did it great, so I'm pretty happy about the final result. Also, I would like to thank Miki for going back to r2lan and start contributing with all the file system stuff, but not only that, because you have been editing the audio of some presentations, and it was improving quite a lot, the quality. And finally, I would like to thanks to Neuroflip, the music that you did for the event. So thanks, everyone, and also thanks for all the speakers that you submit to the presentations, and also thanks for all the audience for joining us. So this is the end, but not the end of the conference, just the beginning. So click the links below and check the presentations you like, and see you later. Let's dig deep into the roots of r2lan.